Hello, everybody. Welcome to the Spirit of Apollo. I'm your host, Mark Lesmeister. I'm going to talk a little bit today about why we have to have a huge rocket to send something into space. Why can't we just launch down a little space capsule and launch that into space somehow from the surface of the Earth? To understand that, we'll have to understand a little bit more about what it means to get something into orbit. In order to understand what it takes to get to orbit, we'll start not with rockets, but with cannons. This would likely please my son James, who loves cannons as much or more than I love rockets. Specifically, we will look at the motion of cannonballs. The first person to really understand the motion of cannonballs was this guy, Galileo Galilei. Galileo did a lot of work for the Arsenal in Venice and would have had the opportunity to observe cannonballs in flight. Now, a cannonball is an example of what a physicist calls a projectile. Now, besides perhaps looking at cannonballs in flight, he also experimented by rolling projectiles off of a platform in his laboratory. Here's a page from one of his notebooks. What Galileo figured out was that the motion of the projectile was two motions, horizontal and vertical. At the same time as the projectile was moving horizontally at a constant speed, it was falling vertically. That meant that if you launched your projectile faster, it would go farther horizontally in the same amount of time that it would take to fall to the ground. Isaac Newton, this guy, took the idea a step further. In a purely hypothetical example, he wrote about what would happen if we took our cannon and mounted it on top of a high mountain. So as with Galileo's experiment, the distance the cannonball travels horizontally depends on how fast it is going initially. But now the cannonball goes a little bit further because as the cannonball falls towards the Earth curves away from the cannonball a little, like this. If we launch our cannonball even faster, it goes farther. If we launch the cannonball fast enough, the distance it falls in a given time is exactly equal to the distance the Earth curves away from the cannonball. In other words, the cannonball goes into orbit by doing something similar to what Douglas Adams humorously suggested would be the way for people to fly, by throwing yourself at the ground and missing. So the bottom line is that what matters most is speed. If you want to get your space capsule into orbit, you need about 7.9 kilometers per second of speed, or about 17,700 miles per hour. And that's just if you want to orbit the Earth at sea level. Now, of course, that's not a very good idea because there's buildings and mountains and things that might get in the way. And the atmosphere itself is going to cause a problem because in order to maintain that speed, the atmosphere has a lot of drag. So you're going to want to get your capsule up even higher above the atmosphere, a couple hundred miles perhaps. And that means that you're going to require even more energy. So you're going to have to give your capsule even more energy at the beginning of its motion. But that still doesn't explain why rockets have to be so big. Why can't we just launch the space capsule itself using a huge cannon? That's what this guy, Jules Verne, suggested in his fictional From the Earth to the Moon. He actually did some serious calculations to go along with his fictional book. However, to reach the speeds needed to achieve orbit, the accelerations that would be incurred in any kind of feasible length cannons would be far too great to endure. We need to have applied the accelerations over a much longer period of time that would be possible with a cannon. And that means attaching our capsule to a rocket. That way the rocket engines can continuously accelerate our space capsule over a long period of time, so the accelerations be much less. Now I'll talk more about what this all means in our next episode. Okay, so now that we know why the rocket is as big as it is, I'm going to go ahead and start putting some more on it. Today we'll do bag 4. So here we show the model with the pieces from bag 4 attached. It finished off some of the trim at the top here. And then it added these ridges, which I'm probably going to have to take a trip to Rocket Park to see if I can identify where those were on the actual Saturn V, and maybe I can find out what they were used for. Till next time, Godspeed.